Testing, testing. Okay, we'll be starting very soon. In about 3 minutes. We started that. So I set up the YouTube live stream just to test it. I'm not quite so familiar with that, but I'm going to close that window. Okay, hi there, greetings. We're just getting ready to start. Okay, greetings everyone. There's a few late arrivals coming today. We begin recording this week's session, and I welcome you to this, and which is now session 4 in our journey into permaculture. And just a reminder, really, is these first 8 sessions. I'm really going to try and look at the theory behind it. I think we need to get the big ideas. We need to see the patterns. The world's really complicated, and as we look into specific circumstances, we can get lost in the details. And it really, permaculture, firstly, is our pattern language. It's a chance to see bigger pictures, and if you like, to understand the generalities before we, and we're slowly going to zoom into the detail. So that's our process. And already people are asking me lots of questions about specific ways to work with permaculture, and of course we're going to come to all of that a bit more in the second term, and then we're going to move into pressing you and encouraging you to use these ideas in your own circumstances. And we're going to move to our design workshop. Just a reminder that you can, everything is being recorded and posted on the Sector 39 Academy website. And and we're capturing this through YouTube as well. So we're aware not everyone can follow the course in real time, and they're going to have to catch up through the videos and so forth. Again, this is a big learning experience for us too, to try and teach in this way. And can we really reach people and have a really good course in this way? And obviously with your feedback, with your help, we can get this right. So that's how I'm thinking about it. I think we're going to be on a steep learning curve, but as we move through into this, what I'm most excited about is hearing back from you, hearing back from the people who are participating in this course, translating these ideas to your own circumstances, and learning through doing, learning through observe and interact, learning through your own experimentations. So that's what we're doing, and that's how we're going. And I'm sort of starting off generally with the generalities. I want you to see the bigger picture. And I'm going to start off by looking at a specific example, and one actually that I was personally inspired by. Just get this so I can see what I'm doing. Great. Okay, so first I want to I just want to name check this guy, Terry Lee, Terry Leah. I think he's Australian. I'm sorry, Terry, if I'm getting you wrong. And Terry not just wrote this book, but also was, as if I understand, wrote an excellent article and helped record a video documentary about the Chikukwa Permaculture project, which is in the east of Zimbabwe. And I like to use this as an example in teaching because it's really inspirational. And so these are not my photos. I believe they are of Terry's. But to say that from a personal point of view was, my permaculture sort of journey began really by being in part being inspired by this project. And I visited there in 1991, 1992. So at the beginning, I was in the beginning to learn about permaculture. And at first, again, I was seeing the project at the very beginnings. And I didn't have the sort of the vision to see how it was going to evolve over time. But I got to meet some of the people who had been at its inception and who created the vision for what is Chikukwa permaculture. So I'll give you a tiny bit of it's a bit of background, but so Chikukwa is a district it's a sub-region within Chimanimani district, which is eastern Zimbabwe. It's actually right on the border between Zimbabwe and Mozambique. And the history of Zimbabwe is one perhaps that many African countries have experienced in various degrees, is there was an input of white settler farmers, and they came in 30s, 40s, 50s and settled the highlands and the good farmland. And many people were displaced to more marginal lands, steeper areas, more arid areas, and more challenging areas to farm. And so those people, Mashona people in this example, brought with them farming techniques and practices that perhaps had worked in one area, but put a lot more stress on the land in this example, in this instance. And what we're looking at here is the sort of the before photo. The Chikukwa is a huge valley, there's 7 villages, I think there's about 7,000 people living there, dispersed over a big rural area. I'm talking now about a few years ago now. I'd be interested to have an update. And these photos are taken from an article which looked at the process from the beginning, from early 1990s, and then projected through into the 2000s. And we could see a sort of a 10-15 year transition of a community, and to think about how they used permaculture to coordinate their activities. So that's the story I want to share with you. And what we're seeing here is a landscape that's drying out. It's been overgrazed. It's had the tree cover removed, and really it's breaking down. What we're seeing here is lots of bare soil. We talked about protecting and covering soil before. Once soil becomes, of course, exposed to the air and it dries out, It's more likely and more susceptible for erosion. Erosion gullies tend to get bigger and accelerate the destruction of the landscape. We're seeing here is settlement, and it's interesting to reflect on where the settlement sits within the landscape, but we'll talk about that a bit later. And what's happening and what triggered a crisis in the community was by the late 1980s, early 1990s, was there started to be erosion, soil loss, a drying out of the landscape, and a lowering of food security and increasing hunger and poverty started to enter into this region. And a group of people came together, and I think it was triggered by, people's wells started to dry up. Springs, places where people had gone to take water, for many years, many decades, started to dry up. And this obviously caused great concern. And the beginning of a kind of thinking of, these aren't small problems, these are big problems that we're starting to experience. And it's going to take a big joined up idea to begin to solve it, to begin to address these things. So we've got to start thinking perhaps about finding easy solutions to problems. Instead, what to think is we need to build long-term strategies that address the cause of the problems. That's permaculture thinking. Okay, so there isn't an easy answer, a quick fix perhaps to the loss of trees, soil erosion, the drying out of this landscape. There isn't an easy solution for the community. What they did was that they reached out and they spoke to people within the permaculture community. And Zimbabwe was one of those countries where there were people who latched onto permaculture very early on. And I believe Bill Mollison taught the PDC in Botswana, 85, 86, something like that. And there were 4 or 5 Zimbabweans on that course who then came back and initiated, started a permaculture training center, demonstration plots, and started, sharing these ideas. So all of that brings us to the beginning of this story, really, which is a community starting to feel distress, and they're reaching out for new ideas, and those ideas come in the form of permaculture. And let's just we'll jump into the next photo and just start to see, we're looking at the same kind of view, looking up the valley now from the other direction. And we're seeing now a few years into the project. And what we're seeing is, look at these lines on contour stretching across the whole valley for miles and miles and miles. Look how these lines that we're following are on the lower slopes, the less steep slopes. Perhaps an observation. Now, permaculture begins with observation, remember. Observe and interact, I told you. So let's use our powers of observation. Let's look at these pictures and let's ask ourselves, what are we seeing? So see how the lower slopes are slightly less steep, and as we go up the mountain, it becomes steeper and steeper. So here we are here, and look how on these lower slopes, the slightly less steep slopes, the community have created what we call a swale. It's a ditch and a bank. And on the bank is planted with tough, deep-rooted grasses, vetiver, grasses that you can easily propagate and from root cuttings, and also grasses that don't set seed and are non-invasive. And they have very deep root systems which help stabilize the soil. And let's look at this. All the tree cover on these steeper slopes has been removed. So when it rains, rainfall comes down with enormous force and velocity and can accelerate along the surface of the ground and start to open out erosion gullies. And these swales and this combination of techniques, the swale and the vetiver, creates a barrier to the water. It slows it down. And when water goes quickly, it can carry obviously soil and sediments and silts with it. But when water moves very slowly, it can't carry the same volume and it starts to deposit. So instead, just by making this intervention, instead of the erosion getting worse and worse, it slows it down and it begins to deposit soil behind where the barrier has been created. I don't want to get too into the details, but just what to think is, so there's a principle here behind this, which is catch and store energy. Think of water as an energy flowing through the landscape, and what we want to do is to slow it down. We want it to go sideways, not downhill. We want it to actually soak into the soil where it can remain and nourish plants. It can do the work that we need it to do. So let's jump into this and let's meet one of the farmers. Here's a lovely picture from one of the farmers, and I believe he's interviewed in the video, which you will find on YouTube. I'll try and find a link for it. This is the Select project in Chikukwa, part of the Chimanimani district in Zimbabwe. So now we can see here is the bank, which is going to interrupt the rainfall and encourage water to soak into the ground. These are the vetiver grasses, which stabilize the bank, and obviously the roots help that rainwater to infiltrate into the ground. Now, the best place to store water is in the ground, where it will still move downhill, but slowly. It can't erode, and then it stays around for a much longer time. This farmer here has diversified. Instead of just having cattle and grazing cattle, he started to grow tree crops. We're seeing also faster growing nitrogen fixing trees, which help build soil, which can be cut and fed to goats and chickens, the manure of which can be composted. The compost can be added to the soil, and then the quality of the soil can improve. So what this farmer here is doing is he's catching and storing energy. He's slowing down water. He's using that water to grow green manure plants, which help build soil, which you can also feed to his animals, which you can then create compost to increase the quality of the soil. He's addressing the source of his problems. Soil loss is now turned into soil building. We talked about the relationship between problems and solutions. We have to tackle the root cause of a problem, and then we turn it actually into its own solution. So this is a wonderful example of observing and interacting, catching and storing energy. We've used simple techniques and observation to understand of how water moves across the landscape. We can slow it down and we can trap it. The big reveal, this is the change in 12, 15 years from a landscape that's drying out, that's highly eroded and is in descent, to something that has been regenerated. Look, as we go higher up the slope, we see the forest cover is coming back. So think of the planning, think of the organizing that it would take to communicate this many different small farmers to begin to behave in the same way. I think this is what impresses me most about this whole story is, yes, we can see how this landscape is regenerated. We can see how well the swale lines and the vetiver grasses have worked. We can see how allowing regeneration on the really steep or damaged areas is working, and how there must be very careful management of goats and cattle and grazing going on. I think the people within Chikukwa Valley have become some of the most experienced and adept permaculture practitioners. because it's that consensus building, it's that communication, problem solving, team building. That's the secret of the project. The techniques are of course important, and then they've got their techniques right, and they've used a combination of approaches. But the really clever thing is the way that they've built consensus across the whole community. So there's a little just window into and I want to just to there's a few different things that I had in mind for this session, and what we're doing is we're doing two things really. Is we're following Bill Mollison's Permaculture Designer's Manual, and I'm kind of trying to using that as a reference to really make sure we get our design thinking right. This long-term strategy building and the tools that we use to make those kind of decisions. That's central to what permaculture is about. It's much more than just the techniques. It's our rationale for understanding how and why we use these techniques. And the other part of the thread that I'm following is these 12 principles. David Holmgren summarized beautifully permaculture into 12 steps and 12 principles. And the first one being observe and interact. Learn from experience. Using your powers of observation, asking fundamental questions, looking at all of the things that we've covered in the first two lectures. Now, third and fourth lecture is informed by this second principle, which is around catching and storing energy. Told to be strategic and timely, to intercept energy flows and to work with them. So let's have a look at some ideas here. So here's an article from a UK newspaper that's saying a third of the Earth's soil is already acutely degraded because of agriculture. Well, if we're dependent on plants to translate some sun's energy into edible, storable forms, and we're losing our soil, that should be sounding alarm bells. So obviously it's incredibly important that we have to learn how to regenerate soils. We have to reverse this erosion, and for sure we can do it, and we can do it by observing from nature and understanding the processes that those soils built in the first place. And that's why I've really kind of labored the point in last week's lecture. Soil and soil formation and soil building is we can understand how that process has come about, then we can understand how to work with that to repair damaged soils and to rebuild, regenerate degraded landscapes. I found this graphic really interesting. In that it is an exploration of what's happened to the UK food supply. So this might be interesting to reflect about in your country and how things might have changed as well. But let's just explore this. So I just let some people in. Okay, we're thinking about catching and storing energy. We're thinking about how our food supply is powered by the sun, and translated through soil to give us the energies that we need. So this is a graphic showing the UK population in millions and the source of our food. It goes back to 1700, so we're back 300 years. So 300 years, population of UK was about 8 million, and we grew all of our own food organically using traditional unmechanized methods, 100%. That was still true in 1750, according to this graph. So that's interesting to think. 250 years ago, we were completely food secure, and our food came 100% from small-scale, traditional organic farming methods. As the Industrial Revolution got underway, 1750s and onwards, slowly mechanization started coming into farming. Firstly with steam engines, and then obviously then diesel-powered tractors and so forth. And so we can see how slowly, as population started to rise, we started to not only fill that gap with mechanized farming, we actually rolled back to traditional unmechanized farming. And also you can see by 1800s, 1820, 1850 is as the British sort of colonial period started to expand, we started to import food from abroad, ostensibly from the colonies. And see how the population rises, 30 million, 1900, we're at 38 million, it looks like. And already, suddenly, in really quite a short space of time, we moved to importing half of our food. That's gone down a little bit now, but also you can see the introduction, 1950, just after the Second World War, in then comes chemical farming. So here's the thing, is just as we moved to mechanized farming, we started to be consuming coal and diesel to power the engines of the farming. And then as we moved into chemical farming, we started using nitrates and phosphates extracted from fossil fuels. So suddenly farming has become a huge consumer of energy. And look how the UK food supply situation has come that it's either imported, which means it's highly reliant on mechanization and fossil fuels, or it's a product of mechanized chemical farming. So in 200 years, farming has suddenly become this huge consumer of energy and of moving resources around the world. And what that does is that undermines local food security and creates all unique kinds of vulnerabilities. And interesting to reflect the transition that maybe countries like Uganda, Ethiopia, Kenya are on. And as farming becomes more mechanized and more chemical and more controlled by global corporations, and that kind of threatens local food security. So permaculture has so much to offer in readdressing some of this balance and understanding that with this kind of mechanized farming, we're not catching and storing energy. We're creating systems that are ever more dependent on resources from the outside, fertilizers, pesticides, transportation, seed technologies, that our food systems are becoming less secure and more dependent on external resources and external inputs. Capture and store energy. So plants translate the energy of the sun through their chlorophyll into sugars, 30 or 40% of which they give off on their roots to feed soil microbes and to build relationships with soil microbes, fungi, and the different organisms, and create a nutrient exchange. Here's the thing, in monoculture systems, in these westernized a more industrial farming system, we grow huge fields of one crop. We sow those seeds at the same time as each other. As they develop, they have the same root depths, they have the same nutrient requirements. They're essentially competing with each other for space, to build those relationships, to access the available minerals and so forth, which actually creates the conditions where diseases can be more prevalent, and that because of competition for nutrients from the same soil profile, the same soil depth, that there comes a need for fertilizers. So patterns. We're learning to see patterns, remember? One of the patterns that we're going to explore is, well, let me wait, I'm getting ahead of myself. Look at the root patterns and understand, just from that picture, why monoculture creates competition, why monoculture pits plants against each other, because they're all trying to do the same thing at the same time. Now look at a cross-section of a natural system, and let's look at the root patterns here, where we've got a huge variety of different types of plant. We've already touched on and mentioned the vetiver and talked about how it has this massive root mass and depth of root, and we'll look at that in future as an example, because it's such an interesting and useful plant. But look at all the plants around you and understand they all have different requirements and they contribute back to the environment in a different way. And that perhaps by mixing plants together, which have different root depths and different requirements, actually, instead of making them compete with each other, is they benefit each other. We start to have mutually beneficial relationships. Look, these shallow plants can't reach down deep, and these deep plants aren't maintaining the surface or building the reactions at the surface level. So when we have mixtures of plants with different root depths and they're growing at different time scales, different time trajectories, then we have a mixed set of conditions. And then actually we're catching and storing energy and cycling that energy within the soil much more effectively. And we're using the whole depths of the soil rather than just a shallow profile at one time. These are our patterns. This is what we can learn from nature through our observing and interacting, seeing the shape of plants and their roots, and thinking about how they operate. Catch and store energy. As plants live, so do they die. And left on the surface of the ground in the hot sun, the organic matter in the plant will oxidize. The carbon in the plant will combine with oxygen in the atmosphere and go off as CO2 and will break down. If we can create the right conditions, we can make compost instead. We can mound up organic matter. We can create the right humidity, the right degree of shade, understand the conditions that those microbes that make compost require. And then we can catch and store the energy of those dead plants. We can learn how to cycle it and trap it in a form which is much more stable, to create humus, that part of the soil, again, which builds the right conditions to nourish the plants. That's all we really need to know. And look, here's an example of a Kenyan friend of ours who's making an excellent compost heap, and he's exploring with different materials and different textures and different processes to create the right compost. These should be our very early experiments as permaculture students, is to understand catching and storing of dead organic matter and how we translate that back into amendments to improve our soil. And every time we make a compost heap, we'll talk about the details about how to do this more effectively a bit later on, and I'll be showing you examples from my garden where I work every week, as well as the compost experiments that I'm doing. So again, patterns to detail, trying to get us to think in parallel with each other, to think the same way as those people in the Chikukwa Valley in Chimanimani were thinking together, so that they could understand their wider objective, which is slow things down, slow down water, get it to soak into the soil, trap the decomposition of organic matter, and channel that into a way in which we can create compost and mulches, which will help long-term soil stability, which help the soil absorb and hold water. So these things are not unrelated, they fit together beautifully. So here we are, here's some lovely compost which has been made here up in Kenya. As I was just putting this slide show together, just digging around and photos from all my different projects, and I thought about catching and storing energy. And I came across this picture of a group of students and volunteers and community members from our community here in Wales working together on a community orchard. And I thought about also in this broader way, catching and storing energy. Think about the energy flows around you. It's not just sunshine and water and organic matter, although those are key building blocks of ecosystems. So think of that human energy around you, not just the physical work, but the knowledge, the momentum, the mutual support that might be around you. And think about how can we also catch and store that energy? How can we slow it down? How can we help benefit from the experience, the muscle power, and everything else of the community around us? All of these are things that we want to build into our permaculture designs. These are patterns that we want to see, how water moves through a landscape, how the wind moves through a landscape, how we can trap organic matter, how we can build soil, and how we can harmonize and work with the people around us so that we can initiate long-term joined together plans. Again, think how the people in Chikukwa must have planned, educated, inspired, and communicated with the people around them. That's what we have to do in permaculture to be effective in the long term and the broader scale. Yeah, sure, it begins with me, it begins with oneself on one's own land. We put ourselves at the center of what we're doing, but at the same time is understand everyone else is doing the same. Everyone else has the same needs, and how do we build alliances? How do we build a common vision? This is, to me, that's at the heart of it all. So community power, the energy of people, and the momentum of what happens if you can inspire some people, you draw in others. And again, that's exactly what happened in Chikukwa. How did they build those miles and miles of swales on the hillside? Well, actually, a small group of them started off doing it. And just like 4 or 5 of them on this massive hillside, and people thought they were crazy. It will never work. You can't do all of that. And what's more, they did it in the dry season when there wasn't much farming work to be done, but there was, obviously it was hot and it was hard and the ground was hard. And what happened was they started, and people came along and they were curious and asked questions, and some people joined in with them. And then it became an ongoing thing. They created songs, they sang songs and told stories about what they were doing. And that helped inform other people around them to understand, what's going on, how can I join in, why would I want to join in? So this is all part of our learning within permaculture, is to communicate, to connect to other people, to build alliances. It's not just you against the world, it's how are you going to connect through the landscape to the people around you. These are our challenges. Ali Tabendeki, I noticed you posted a lovely picture of a banana circle earlier, and I grabbed it and put it onto the web page for this week. And here's just a simple example: catch and store energy. Here's a hole in the ground. a hole in the ground that's maybe strategically placed so that when there is rainfall, that rainfall is encouraged to flow into the hole and to soak into the ground. So here's something I'm going to teach you this week in the line of catch and store energy is water always flows downhill unless you add energy. So gravity. So when it rains, water comes from the sky and from above us. And once it hits the ground might become saturated and that water might begin to flow downhill. We can predict where it's going to go. We can create, we could contour and shape the surface of the soil to funnel rainwater where we want it to go, to make it go where it can be useful. We want to slow it down. We want it to soak into the ground. So we can create individual structures like something like a banana circle, which gives somewhere for that water to go. We could fill that hole full of dead organic matter that's going to help absorb and hold that water and also slowly break down and feed the bananas. We can plant the bananas not in the hole, but on the berm, on the bank around the hole. Those roots will find their way into the moisture. They'll benefit from the moisture that's there. But what's better than planting the banana in the hole is to create a place then for all your mulch to go, for all the dead leaves, all that dead organic matter. It's going to not only break down and release nutrients and feed the soil microbes, but also going to help channel water and maintain long-term humidity, which of course the bananas like. We can think about a guild of plants. We could think about, the deep-rooted, the shallow-rooted. We could think about the plants that grow on the surface, maybe like pumpkins, things that go sideways that maybe help cover the soil. And then think about the profile of the garden as the trees grow. Now, let me just see if I can just quickly find that lovely picture that Ali shared with us. Maybe I can't do that. I don't know how to do that. Okay, maybe I can't do that. Somewhere. Sorry, I managed to get lost into that. I did place it somewhere. Let me just give me 1 second. I'll 1 second. Bear with me. Here it is. This is the web page for today's session. Patterns, seeing patterns, and here is a lovely picture that Ali supplied of a more established banana circle. We've got ground cover plants, looks like pumpkins going around at the bottom. We've got mulch, we've got the pit to receive the moisture, and we've got the bananas establishing. Building relationships, creating a system that effectively catches and stores energy. That's our objective. Okay. Go back to this one. Let's go a little bit deeper into this now, because this is very, very important. And this is the building block. Our first strategy in permaculture is to catch and store energy. It's to slow things down. We want water to soak into the landscape. We want organic matter to be trapped into compost. We want to energize the people around us and give them a common vision so that we can begin to work together and begin to release the energy that is within our communities. And we can't do that if we can't communicate a collective vision. So this is, again, I think one of the immense power of permaculture is that it can help us build consensus and build long-term strategic goals, which and then slowly develop and help us meet our own needs. So I need to tell you a story about a remarkable man who is still active and who has inspired a great many people. His name is Yakuba Sawadogo, and Yakuba is from Burkina Faso, and he's from the Sahel, from that semi-arid belt, the southern edge of the Sahara, and he grew up in one of those communities, rural villages, where the land was becoming increasingly arid, and slowly young people like him, when he was a young man, were drifting away and heading off to the city. He had a business. I think he was maintaining motorbikes, had a little garage. And as the years went by, he just saw more and more people arriving in town, coming in from the rural areas and kind of competing to find a place in the city. And he asked himself, if everybody's leaving, what's left back in the villages? And at some point, against the whole flow of everything that seemed to be happening around him, he decided to sell up his business and to go back to the villages and to try and help regenerate and rebuild the communities that were obviously being consumed and being lost by this rural to urban migration. And obviously, and what he witnessed when he got there was to see also the landscape drying out and the trees being removed, and in these areas where his is quite flat, hard ground, baked solid like brick in the dry season. And so when the rain comes, so the water percolating in flows over the surface. Now, he was aware of traditional techniques called zai, of maybe excavating small holes in the soil surface. And I need more pictures really. That instead of allowing water to flow away over the surface, it infiltrated into the ground. In fact, I need better pictures of this. This is a much more intensive system than one that Yakuba developed. He would just literally take his hoe and just pockmark the surface of the ground, break it open, so that rainwater then was encouraged to infiltrate. And one of the things that he also discovered was, if you break open the surface of the ground with your hoe and make a small indentation, so that might fill with water when the rain does come, if you add a handful of compost or manure into that hole, it holds the rainwater for longer. He tried adding termite eggs into the mix, so that when the moisture came and the soil started to open up, the termites would burrow down into the ground and start creating subterranean tunnels, opening up the soil. He started thinking about a very simple combination of techniques, using the resources that he had to hand, that might help kickstart the regeneration of this soil. And so this is what happened. The areas of the land where he made these interventions triggered the germination of indigenous scrubby trees, of nitrogen-fixing, hardy, pioneer trees that then could be harvested and composted and fed to animals and help build soil and kickstart the regeneration process. And it's these observations leading to catching and storing energy that allows a process then that reverses something that was breaking down and eroding to something that's slowly building up and accumulating. This is what Yakuba set in motion, and he had more impact. He was more successful at tree planting by triggering this regeneration, then all the UN projects and other global NGO projects that were coming into the area, just one man, through the power of his observation and the power of his ability to inspire and inform the people around him to follow on the same techniques and to understand the principles behind it. Now, he wasn't necessarily using the word permaculture. He wasn't necessarily talking about these principles and ethics in quite the same way, but he was actually living within the same observations. And permaculture is hugely informed by the experiences of people like Yakuba, people like you, wherever you are, applying these ideas in your situation. Remember, from patterns to detail, you're learning the detail because your situation is unique. Your soils are different to mine, your community is different, your objectives might be slightly different, but the overall pattern unifies us all. That's what Yakuba learned, and what he was brilliant at communicating and inspiring people around him, giving them literally the tools, the concepts. They could just literally follow him and copy what he was doing. And slowly, they started to have an aggregate impact. Many people making small interactions, but in a coordinated way, has a really big long-term impact. Just like we saw in the Chikukwa Valley in Zimbabwe. This is the power of permaculture. I'm interested, of course, individual food and livelihood security. We want to improve our own, empower ourselves to be more effective. But permaculture, when it joins together at the bigger level, has the ability to transform whole communities. That's what we're looking at. That's what we're trying to do. And so mulch, putting dead matter on the surface of the ground. We can have a living mulch with green manure plants that we grow to feed the soil, or we can have a dead mulch of using dead matter. And here we have an example that we're seeing the soil is cooler, there's less evaporation, you're creating the right conditions for the right soil microbes, encouraging soil fungi to form. These are the patterns we want to follow. We can look these examples of I think this is from the Canary Islands, but another example of using available local materials to interrupt the surface flow of water to create little localized conditions that we can then use to catch and store energy, slow down the movement of water, help the accumulation of soil, and off we go. Work with the process of succession. I found this graphic somewhere, I think it's on a Facebook or something, but it catch and store energy. So here what we're seeing is maybe the planner, the designer, or the owner of this land, and he's seeing now the shape of the land, the pattern of the land in terms of its contours. He's thinking about, how do I trap as much water in this landscape as I can? Look how we've got little ponds, we've got slowed down the flow here with a dam and a berm, we're excavating a big pond here, and there's water everywhere that we can look in the landscape. And there's also a sense of the contours. Water flows downhill, remember, and comes from the sky and ends up at the bottom of the landscape. What we want to do is to slow it down, and we can predict where it's going to go, because if we understand the shape of the landscape, we can understand how the water is going to move through it. All of this we can get by using simple observation techniques, and then building a strategy to catch and store energy, joined up long-term strategy. Once you've got this hard landscaping right, once you've understood how to trap water in your landscape, you won't have to, you don't have to keep redoing it. All you're doing is reinforcing it and asking yourself, how can we improve that? We can always do a bit more. We can keep adding to a system like this, so that slowly we slow down and trap more and more of the rainwater that comes into the system. And we're going to look at how water works on sort of macro systems in a later lecture, which I hope to fit in today. But let's just begin to think now about this idea of how we approach catching and storing energy. by seeing patterns, seeing how these key elements that we need, soil and water, how they behave. So here's some examples of contour catchment. A swale. Look, it's a ditch. It's on contour, it's level. So when there's water in that ditch, it's not going to flow sideways, it's going to sit there. And over time, it will then slowly soak into the ground. Look how in this place, maybe they get very heavy downfalls of rain. So maybe the landscape becomes, saturated quite quickly. So they've built quite a high berm. This is the upside, this is the downside. Water's going to flow this way, and then it's going to well up. And if you're building a water catchment, you want it to be high enough and wide enough and deep enough so that when you get a rainfall, it doesn't flow over the top. You want it to sit behind it and soak into the ground. So you're not looking to compact all of this soil. You're trying to make it there to receive and hold the rainfall. Think how you might walk your land, you might measure it. We'll talk about A-frames and contour measurement. Understand the shape of your land. Understand how water is going to move through that space, and think about how it might accelerate downhill. The steeper the land, the faster the water is going to move. The more dangerous it becomes, the more erosive it becomes. Now let's just also think about climate change, global warming. What global warming means is that more of the sun, the heat from the sun, is trapped into the atmosphere, which energizes our weather systems so they become more extreme. It's like a spinning top that's moving ever faster or something. So when we get rainfall, it's heavier. When we get drought, it's for longer. So our landscapes are becoming more and more vulnerable to erosion from extreme weather events. And even if they only happen once every few years, the impact of once you've lost your soil, you've lost your soil. These are things we need to get right. We can understand the shape of land. We can understand the shape of the rainfall. We can see those patterns, and we can start to begin to plan for how we might create a catchment system that can hold that and manage that rainfall. Now, this picture's extreme. It says it's from Bhutan. I actually don't know whether it's for real. For me, that looks like an artist's impression. But if even whether it's made up, whether it's true, that's such an extreme form of catching and storing energy. Insanely, that slope is these are terraces, by the way, not swales, but it's the same fact. I can't imagine that that's really real, but if it is, it's just jaw-dropping. But there's an extreme. But think of the understanding of the landscape and its shape and the pattern of rainfall that would be required to have a system like that that works. Here's a simple rainwater catchment integrated into a building. I think we've all seen examples of that. And a lot of people, when we talk about, many students, many people, when we talk about water catchment, they immediately think about tanks and storage tanks. And yeah, fantastic. If you can hold the water above ground, you can then you could flow it out through a tap, and you can use that as becomes a very high value store of water. I would say though is that the best place to say it again, the best place to store water is in the soil. That doesn't cost anything, other than perhaps shaping, terraforming the landscape to help it receive and trap that water. We looked at banana circles, soakaways, swales, ditches, banks. We can think about dams and all sorts of other things. So tanks, high value, cost money, need to be maintained. Don't look after it. They crack and they break. They fill up with detritus and block. All of those are considerations. So I would say it's great to have water in a tank, brilliant. But that's so high, it's high value. I would prioritize that for drinking water. I'd prioritize that perhaps for a nursery or something. But otherwise, Don't think that you can only store water in a tank above ground. There's many other ways to do it, as we've already seen some pictures of it.
Can I ask a question?
Yes, please.
Yeah, sorry I came in late and missed a couple of sessions. Um, it's probably a stupid question, but as I'm a
There's no
beginner,
such thing as no
can
such
you
thing as a stupid question, Kim.
can you so I'm fascinated by this idea of storing water, what you're just talking about in the soil. But can it ever be, like I'm in the Netherlands where it's all flat and a lot of rain. So can it ever be too much water in the soil? Or are you talking about building ways to capture it in smart ways so that it doesn't kind of flood your plants? Or do you see what I mean?
Yeah, so it's about understanding. It's a really good question, and of course, So I'm talking in a very general way, and especially the features and techniques I'm talking about are very much for arid and semi-arid landscapes, and especially for our friends in the tropics and more tropical areas where they tend to have dry spells and then intense downpours. Is that makes it hard for the land to receive and absorb that rainfall. So these techniques are very much that end of the scale. But what's interesting, is Holland is going a bit unique because you're a country that's below sea level in many places. So we can chat about that in a minute. That, of course, even here in the UK, we're starting to experience these same energized weather systems. We're going long periods without rain, and then we're getting torrential rain and instantly get floods. So there's a very close relationship between drought and floods. So it seems counterintuitive, but the two go together. In Holland, where you're close at the water table, and perhaps water shortage is less of an issue, I would be probably tempted to build up. So if you imagine you have your raised beds sitting up above the surface of the ground, because the roots of the plants will always go down deep and they'll access the moisture that's there. So I would be using similar techniques, but I would be trying to understand the uniqueness of your, specific situation that you're in. I think there's only one hill in Holland, so or something like that. So it's a slightly different set of constraints. But what we know is plants need humidity, and that humidity, that rainfall is going to end up in the soil, and you know it's always going to end up going downhill. If you start to have, as soon as the ground becomes saturated and flooded, then that's going to push the air out of the soil, and then all of soil life slows down because the organisms that build your fertility are all aerobic. So that's why I would go up if I was worried about flooding. I would have raised beds or ditches and banks or something like that. So again, there's somewhere for the water to go and the plants can sit above it. We move from patterns to detail. Yeah, great. Thank you for the question as well, and please, anyone else, don't be shy to jump in. We're looking at a big scale picture here of a landscape, and we can see by observing that landscape and making predictions, we can guess the way that the water will flow, how surface runoff will obviously gather into streams and find its way downhill in increasing in velocity. And in this technique, what we've seen here is, but we don't want the water to all gather together into a single stream and to grow in velocity because it's going to erode. We want to slow it down. So in this instance, we have a spreading bank, a berm, put across this water flow. So when we get a seasonal flush or rainfall of water, of a drain of water, it's slowed down and it's trapped within a series of growing systems. So again, it's by looking at observing, seeing the generality, seeing the pattern, we can then put in interventions that are going to catch and store, slow it down, make it go sideways, make it soak into the ground. These are our lessons. These are the big lessons. Here's another example where some of the flow, look, there's an interception here, some of the flow of water is encouraged to go off to the side and again to seep into level ground where we have a crop. And we might be able to interact with this here to choose the proportion of, we don't want too much water to come this way. Now, here's a simple observation is, here's an example. We've got a water catchment and a river. That could be a road. That could be a footpath. Think about what happens when you have a heavy rainfall. Where does that surface flow go? Can you interact with it in a way in which you can take some of it or all of it and to soak it into a place where it's useful? Again, observe and interact, catch and store energy. These are our first two steps in permaculture. So we're always looking around, trying to understand the patterns that we see around us. Now, here's the thing. I wanted to just touch on, this is a ram pump. And I'd never heard of these things. I came across one on the farm in Zimbabwe that I came to, and I was utterly fascinated. And it took me a little while to understand it. I'm not the most, anyway. So let's have a sense of what we're looking at here. And there is a river, a stream, and it has flow. It is going downhill, okay? And what we're seeing here is there's a bay has been constructed. It's going to. Was that a question? No, someone's got their mic turned on though. So look here how some of the flow from this stream is diverted to irrigate crops. And in this example, some of the flow from the stream is diverted and it flows downhill and into this ram pump. What the ram pump does is it will take about 1/10, it will use the energy of the, so when water's flowing downhill, it gains momentum. And the energy from that is then used to flip a valve over inside the pump. And that pushes a parcel of water uphill, up this pipe. And about 90% of the water that came down this route here, PL, will be ejected and will return to the stream. But 10% of it will be pushed up the pipe. And look, what we're seeing is, by taking the energy from the stream, we can put a small part of the water and send it up to be much higher than it started out from. So that's catching and storing the energy, the flow from the stream, and converting that into pressure, which is then pushing that water uphill. And look how now we've got a lovely little irrigation scheme up above this settlement. Going through these crops, got a little fish pond, and multiple benefits from that water. Once water has gone into the river, or it's flowing out of our system, we've got to do work to bring it back uphill again. And carrying water uphill, if anyone's tried it, it's really hard work. What's wonderful about these ram pumps is there's one moving part. There's no power needed. It's only using the energy of the stream, and it can work 24 hours a day. Just tick, 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 ticking away, pushing that water uphill. So catching and storing energy, building strategies and techniques that ultimately create yields that feed us and nourish the system. It's permaculture. Let's think about these aquaponic systems. Maybe we could get a bit more into this a bit later on, thinking about catching and storing energy, cycling nutrients. Think about the relationships between the plants that clean the water and the fish that obviously supplies the nitrates that are feeding the plants. Examples of permaculture settlements, catching and storing energy. Vision for kinds of cities that are cleaned, humidified, and by the plants that are within it. Get ahead of ourselves, but I want bring these ideas alive for us. So I'm gonna check out, jump out of this slideshow, and we'll maybe pick up on some of these things later. And we've been talking about catching and storing energy. I think there's nothing more important than water. So let's take a few minutes out now just to slow down our thoughts. Bill Mollison says in the Designer's Manual, in the future, we'll value land by how much water there is on it, its potential to hold water, rainfall, the ability to hold it, because water is the ultimate limiting factor. If we don't have water, we actually can't produce anything. So land without water is kind of worthless. It's really about how big it is. If we haven't got water, we can't do anything with it. Life happens in water. So it's always going to be the ultimate limiting factor. If we can understand how it works, understand the properties and the movements of water better, then we can increase the potential and capacity of any system that we're in. Water's absolutely vital. So when we talk about catching and storing energy, we talk about using natural components to build systems. We're really focusing water. So water and soil and water. There's a really fundamental relationship there. There's a fundamental, building blocks of everything that we're interested in. So this is worthy of spending a bit of time on. So take a bit of a breath. I hope I'm not going too fast. I do welcome questions and feedback. Water. There's lots of water out in space. Apparently, it's not such a scarce thing. Even the rings of Saturn apparently are ice. And one of the moons there has water on board. And I think some of the water on Earth arrived as a comet. Some of it, we don't need to know all of that, but it's just interesting to think about it. This incredibly important, nourishing thing, and life. We are carbon-based life forms, and we need water to exist. So, very important to think about the value of that. Now, we might all know and be familiar with the hydrological cycle, with the Earth's. Where does rain come from? What's going on here? We talk about water shortage. We worry about water scarcity, droughts, and so on. Water's not going anywhere. The amount of water on the planet is the same amount as there was a million years ago. It's not draining down into the center of the Earth, or it's not going off into space. It's cycling. Water cycles through the landscape. And I'll say something else, is that water, humidity, is the product of a healthy ecosystem. So when we have a healthy landscape, we have a good water treatment and good water cycling. And there's a fundamental relationship between these things. Let's explore this picture. And we'll just start off with that and think okay, so the sun shines down, energy coming into our system, shines on the sea, shines on the lake surfaces, shines on large bodies of water. Let's think about the sea and the ocean for a moment. I think huge amounts of evaporation must be coming off the oceans, and water turns into a vapor. It rises into the atmosphere because it's warm. It's the addition of that heat, energy going in, vaporizes the water. It rises in the air. Warm air rises. It takes the droplets, water droplets, up into the atmosphere, and they start to cool down as we get higher. The water droplets start sticking together, becoming bigger and heavier, and then eventually return as precipitation, as rain, maybe snow or ice. And this is a continuous process. Water is evaporating into the air, becomes more oxygenated, it's interacting with whatever particles are in the air, forming into water droplets, returning as rainfall. Continuous process. Well, as that warm, moist air travels, again, simple fact is body of water takes longer to heat up and cool down during the day. The sunshine is absorbed by the ocean, and the ocean will become warmer during the day and then obviously cool down during the night. The same happens on the land, but it happens more quickly on the land. The land heats up more quickly and cools down more quickly. So you get a pressure difference between the land and the sea. So that means that for at least half of the time, the air is flowing from the sea over the land. And that's warm, moist air flowing over the landscape, slowly being pushed higher as it comes across the warm air coming off from the land, and then also as the increases and the land rises, pushes the moisture higher up. Again, as it cools down, it's likely to rain. And it's a constant process then of humidity being contributed to the landscape, interacting with gravity, flowing down, forming, soaking into soils, soaking into deep, into bedrock, into deep aquifers, flowing over the surface, contributing to little tributaries and rivers and lakes, and always constantly re-evaporating and being returned to the atmosphere in the process of draining back to the sea again. So there's actually multiple cycles going on. It's not just it's coming off the sea, falling as rainfall and going back through rivers. It's cycling many, many times. So this is our goal as permaculture designers, is to think, how do we trap the water in the landscape and then make it cycle as many times? It gets used many, many times over. Okay, let's just have a little think about water and water scarcity, and think that there's an awful lot of water, but most of it is in the ocean, and that is salty, saline, and it's also at the bottom of the hill. It's going to cost us a lot of energy and work to pull water out of the sea and move it uphill, and to remove the salt, because obviously that would kill any plants. Of course, the sun is doing all of that for us for free. Of all of the water that is on our planet, 93.8% of all water is in the ocean at any one time. So there's a lot of water, but most of it is not very available, and it's salty and it's in the ocean. As another nearly 2% is locked up in glaciers and permanent snow. That is decreasing. And there's also about 4% is in the groundwater. It's there deep down in the bedrock, and maybe not moving around. Not only maybe a small percentage of that is actively exchanged. Look, there's a tiny proportion of all the water is in lakes, even smaller in the atmosphere, in rivers, and then trapped within life itself. So look, 93.8% of water is in the sea. Another 2% is in ice, and 4% is deep down in the ground where it can't really be reached. So there's less than 1% is actually available to us in terms of being fresh water. Only 1%. So we need to value fresh water enormously and understand what it is and how valuable it is. Let's just say fresh water is only 3% of all the water on Earth. Okay, so some of that caught up in ice is sort of on both sides. Okay, 75% of fresh water is in ice. 13% is more than 800 meters down in the ground, beyond reach. 11% is in groundwater that is potentially within reach. And then again, less than 1% is caught up in lakes, soils, atmospheres, and rivers. So any point in time, only really 1% of the available water is available to us in a fresh form, which is above ground and not in the ocean. When I first saw this diagram, I was kind of mind blown by this. So we're used to seeing the Earth as a blue ball, aren't we? And we try to think, we know that the oceans are deep, and so we imagine there's really a lot more water than there actually is. Because really the water that is in the oceans is only a thin film compared to the width of the planet, the diameter of the planet. The oceans are a couple of miles deep at the most. So if you were to put all of the water on the Earth into like a snowball, you imagine it as a three-dimensional shape, and compared to the planet, it would be relatively tiny. And then the amount of fresh water is barely 1% of that. So that little blue dot represents all life on land, all freshwater life is dependent on that tiny drop of water. When you see it like that, you then begin to understand how water management is so key. And that if we, depending on how we behave on the land, that fresh water is going to return to the sea more quickly. We want to trap it and work with it and build up. We need more fresh water. So again, look at our hydrological cycle, the global water cycle, land and sea. And we see in here how of the air joining into the water joining into the atmosphere. According to this, 84% originates from the sea. 16% is being returned to the atmosphere from surface storage, evaporation, and from biological storages, as in plants and animals. So there's our 100%. And then we're seeing precipitation, look at the rainfall. And let's think about when that rainfall happens, let's think about how it is intercepted by the landscape. Let's think about how rainfall might be moderated by landing on trees. Think about how rainfall might affect when it lands on bare soil, how that overland flow contributing to streams and rivers might accelerate and erode. Whereas when we have interception, rainfall is slowed down by presence of plants, trees, surface storage, it has a chance then to infiltrate and seep into the ground and replenish our groundwater storages. There's going to be a through flow. That rainwater, as it percolates into the soil, is still going to move downhill, but just much, much slower. And as it moves slowly through the landscape, it can obviously hydrate and nourish plants, but also is at certain points it's going to re-emerge on the surface, lower down the slope. We're going to see springs and issues and sources of streams and so forth. So think about how, as we move down through a landscape, it's going to become more saturated, to be more water available lower down, and there's going to be springs and issues happening on the lower slopes. And the more that water is intercepted and infiltrated on the higher slopes, the more effect we're going to have on the lower slopes. This is your Chukukwa. This was the diagram. This was the understanding that informed those people in the Chukukwa Valley in Zimbabwe that we saw at the beginning of this lecture. And think about how, obviously, farmers and cultivators, it's these lower slopes that are going to be of the greatest value to us, where the greatest humidity is going to be. And these higher slopes need to be forested. They need to be protected from the heavy rainfall and the steeper slopes that are more vulnerable. So think about how different routes that water might take as it crosses through a landscape. And that this overall cycle that is going on, and all of our ground on land strategies are about interrupting that flow. We want to really eliminate the overland flow, and minimize that so that we're losing the smallest amount of rainfall as possible, depending on our environmental circumstances, the climate of where we're at. Now, I like this drawing. Maybe takes a moment to focus on, but this is very, very worthwhile. And it's the same story, but within a bit more detail. And what we're seeing here is, here's our ocean. Here's our evaporation. And it's, so you can imagine the clouds that are forming here at the beginning above the ocean, are the water within that cloud is 100% of sea origin. It's evaporated seawater. It's no longer salty, and it's ready to nourish the landscape. As the rainfall moves over the landscape and the rainfall starts to fall, some of that water is going to find its way into rivers, 26% according to this, and find its way back into the sea again. Whereas at least 25% of the water will be re-evaporated and 50% transpired by the trees. So what we're actually saying, what this part of the diagram is saying is, actually only about a quarter of the rainfall that lands in these lower slopes goes back to the rivers. 3/4 is re-evaporated. Evapotranspiration, that's a great word, is returned to the atmosphere by evaporating off the leaves of trees, and by obviously the transpiration of the trees. As they grow, they give off humidity. As something else is happening though, is that where's that rainfall? Look at this rainfall, it's fallen down onto the forest and then it's re-evaporated into the atmosphere again. As the water is re-evaporated, it's transformed. The water now is carrying droplets, it's carrying bits of DNA, bits of material that were on the surface of those leaves, mineral particles. It becomes sort of charged with biological matter and with mineral matter that changes the nature of the rainfall. And we see as we move into the landscape now, 40% of this rainfall is of forest origin. It's re-evaporated water. So we get 50% as we come into here. We're introduced this idea of Ekman spirals, about trying to imagine how the water is rising, falling, and then rising and falling, and it's like corkscrewing its way across the landscape, actually building connection relationships between the elements of this system. Here we've got a little cylinder, a little area to sort of cut out, and we can jump into the system. Oh look, and see at this section, let's just understand how in this forest system, saying 25.6%, I don't know how it gets to be so accurate, but basically a quarter of the rainfall lands on the trees and then is just evaporated off again. Never even touches the ground. And another nearly 48.5, nearly 0.5% is taken up by the roots of the trees and transpired out through as they photosynthesize. And only a quarter finds its way into streams and rivers and flows back to the sea. And it's very importantly, it's saying here, evaporation from the forest floor is 0%. Water is, so there's no evaporation in a stable forest system. The soil, the ground is permanently moist. Think about how there's all organic matter dropping down from these trees permanently, leaving a mulch layer, which again holds and reduces that evaporation, holds the moisture where we want it. Water is returned to the air by trees helping create clouds, transpiration. The release of water through the pores of trees and other plants accounts for up to half or even more of all moisture returned to the air. So here's thought of how we move through this landscape. Suddenly, at this stage, what it's saying is maybe 100% of this rainfall has been generated by the forest itself. Without the forest, we would be having no rainfall here at all. That we need to understand that there's a relationship between the rainfall throughout the whole of the system. And we get very, very special conditions. Also, is as we get higher up the landscape, it's in certain conditions, we get things called cloud forests, which is when the precipitation and evaporation are equal to each other. So there's a permanent cycling of water. Now imagine that. So, and these are some of the most dynamic, the most alive, the most biodiverse systems in the world are in this place where there is a continual cycling of water. These are the patterns of nature. These are the patterns we want to learn from. This is what nature's kind of teaching us, is where we have the correct assembly of the conditions of life, water's permanently circulating, spiraling, corkscrewing through the landscape, being held onto by plants and organisms, and constantly return to the atmosphere, rehumidifying the atmosphere. If we can get this right, landscapes don't dry out. We don't have droughts. There's a very significant contribution. We talked about the climate change effect, but also in our farming, our agriculture, our landscape management, our cities, everything that we do tends to accelerate the passage of water back to the sea again. We tend to compact ground, remove trees, create drainage features. We hurry, roads and hard surfaces and buildings. All of these things encourage water to accelerate downhill, where actually the thing we want to do is to slow it down and make it go sideways. And to understand that we interrupt this system in one part and we can affect the whole system. All of these slideshows are available for download on the resource page for today's lecture, by the way, and you can explore them in your own time and go into it a little bit more deeply. Some of these pictures you can really spend hours looking at. There's so much going on in them. This is, I took this picture in North Wales. I was driving up through the mountains. It had rained and the sun was coming out. And what we're witnessing there is evapotranspiration. We're seeing how all of that humidity that's landed on the trees is immediately being, it's evaporating, rehumidifying the atmosphere again. And just think about almost as like the earth breathing in and out, and the moisture rising and falling. This was actually on the same day, but later on that day, and it's getting cold now, and all that humidity that gone up into the atmosphere is now starting to condense and to form down and to land as mist and dew. And it's taken me a while to understand just how important dewfall is. We're very accustomed to rainfall, but also as the day gets hotter, there's more humidity can rise into the atmosphere. As the day gets cooler, those water droplets slow down, they become heavier, and they start to precipitate out again. So again, think about the earth breathing in and out. Think about humidity as a cycle, not just an event. Rainfall comes, rain goes. Think of it as a cycle. Think about how the passage of humidity through the landscape it's all related. And then think about how if we use more and more techniques to catch and store, to slow it down, we're actually starting to rehumidify the whole landscape. These are our techniques. Now, of course, if we're only thinking about our own little bit of land and our own yard, we can only operate at a certain scale. We can still use these techniques effectively and to maximize, but really water happens over whole landscapes, vast mountainsides, and that's where we need to join together. And that's why I started today's lecture with the example of the people in Chukukwa, to see how they had coordinated on a very big scale, on a water catchment scale, and their whole valley. And these are our ways forward. So I'm just going to check the time, because it is 6. We've been going for an hour and a half. I'm going to take a little break. I don't want to just push everyone too hard. Let's just take a moment I shall pause the recording, and we'll just take a few minutes. Okay, and just please, if you have any questions or anything or any feedback, I'm happy to hear that. And meanwhile, I'll just allow it. Let's see, the time is 3 minutes past 6. I will return and begin again at 10 minutes past. So I shall see you in about 7 minutes. So replenish my coffee cup. Okay. Let's go back to recording our session, and thank you for your comments, everyone. Lovely to see people here and interacting with us. Yeah, important stuff. I think this is something we so I wanted to just spend a little bit of time looking at these wonderful illustrations from Bill Mollison's book. He's encouraging us here to think a bit about how rainfall reaches the ground and how it interacts with trees, and to think about how the force, the gravitational force of rainfall, large droplets, as it comes down through the air, they stick together, they become bigger, and they hit the ground with an enormous force, which can be erosive. It can compact soil. It can obviously, start to erode it, which is the very last thing of what we want. Whereas it's very carefully illustrated in this picture is the kinetic energy, the force of that rainfall is immediately removed when it hits the tree, the tree canopy. Those big rain droplets shatter into tiny particles. They create a mist. The erosive power of the water is immediately greatly reduced by it hits the tree. Plants are very clever at allowing to create a flow over the surface. Rainwater, then when it's had the energy taken out of it, flows over the surface of the tree. Some of it will come into the middle. Look at it showing here how some of the water is accepted by the plant and flows in, down the stem, and is trapped and nourishing the heart of the plant. But also, when you observe, look at plants, when you see them and see how leaves are kind of balanced. And what happens was the first raindrops fall inwards, and then as the leaf gets heavier and it leans outward, then the excess rainfall is shed off the outside of the tree. So we get a crown drip. And we might observe is that the water needed for the tree is retained to the heart of the plant, and the surplus is given off and can contribute to the wider system. He mentions how the storage of moisture within the crown is a significant part of the water storage in the system, and he also starts to think about all of the interactions in and around the tree with different organisms and little niches that all in somehow contributing to this greater whole, this ability of this plant to regulate its environment, for it to interact with the flow of water, to slow it down, to take what it needs, to shed the surplus and make that available to other elements in the system. So we need to value the contribution of many parts to this whole transaction. And we're also encouraged to think about how the quality of the water is changed and amended as it flows through the system. Nutrients are taken up by the plants and other organisms interacting with, and the water that's returned to the soil has been re-energized, if you like, it's by the interactions that it's made with other living organisms. And I love this picture, another one from Bill's book, and going beyond maybe than just how we think about interaction of rainwater, plants, and soil. That's what we're interested in. Bill's taking it a step further in this picture, and he wants us to begin to think about the relationships between the elements in this system. Now we're starting to think about what nature's teaching us, what our observations are teaching us. So in our picture we have here, it says the system acts as a teacher. There's you, there's the student of nature observing and interacting. What can we derive and what can we learn from observing nature? Well, we've already thought about how plants interact with the flow of water, how they take the energy out of it, they create surface area for both re-evaporation and for its absorption, but its incorporation in the system. So we're already seeing the tree as a translator of energy. We're also thinking about, look, there's the sunshine in creating the sugars through photosynthesis. Those sugars, sometimes as much as 40%, being pushed off on the roots of the plant, and think about how the roots of that plant are actually seeking out into the soil, building relationships with mycorrhizal fungi, building relationships with soil bacteria, building relationships with those building blocks of soil fertility. So we're encouraged to think about how the tree translates energy and water from the air, changes its nature, and how it then incorporates it into the soil. Bill also wants us to think about this tree as a cooperative. Don't just think of the tree and the leaves. Think of all those little bugs and little insects that are feeding on the tree, that they're through their little dewdrops, aphids, they're returning sugar to the soil. As the tree is grown, so it's being eaten. I think every surface area, every surface of that tree is being in some way attacked, eaten, and the sugars are being returned to the soil and then incorporated into the soil and then reincorporated back into the tree again. So instead of perhaps seeing these insects and other organisms living in partnership with the tree, so stop seeing them as pests and as challenges, but understand that they're part of that plant's cooperative. And we're encouraged to think about guilds, about communities of plants and insects and animals and birds that are interacting together to maintain a whole. And the next thing Bill wants us to think about is actually one of these plants, rather than seeing this tree as an individual, it's a cooperative. It's translating energy, it's storing water, creating opportunities. But it's also building relationships with other plants. It's through the mycorrhizal fungal network, the roots of this tree are fused with the roots of the next tree through the fungal hyphae. They can exchange water, they can exchange nutrients, they can exchange antibodies, they can exchange hormones. Plants can signal to other plants that they're about to come into a flowering cycle or pollination cycle through the fungal web. So we increasingly, as we study nature, we understand that everything's connected, everything's communicating some way, everything's connected and communicating with everything else in the system. And all of these elements are conspiring together to catch and store energy, to hold it in the system. If it's not in the tree, it's in the soil. If it's not in the soil, it's in the plants and the vegetation. And that's constantly being cycled by these interactions with these other living organisms. We're starting to think about how systems work, how energy and gases are entering and leaving the system and being changed by their interactions. I think here we're encouraged to think about birds as messengers, distributors of seeds, of nutrients, connecting elements together by transporting, sometimes by huge distances. Think about how there might be new information entering this system from migratory birds and bringing in seeds from other places, or insect spores or fungal spores, insect eggs, whatever. Dynamic, connected systems that conspire together to catch and store energy. This is your model. This is what nature wants to teach you, and this is what you can bring into your farming and your gardening. What to understand is we're using these words like cooperative, guild, community. These can be human systems too, So maybe nature isn't just teaching us about the earth care, it's teaching us about the people care. It's teaching us about society and relationships. And I think these are vital lessons to learn and to bring into our own understanding. Let's look down on that forest floor. Look at that moisture, all that fungi there, mushrooms coming up, and that's telling us that there's a mycelial mat beneath there that's dragging that dead carbon deep down into the soil. Mycelium, the hyphae, the little tubes, the digestive tracts of the fungi, are made of a hard form of carbon. As they live and die, the mycorrhizae, the fungal hyphae, leave soil carbon behind. Carbon-rich soils hold water better. Carbon soils have more air spaces within them for soil microbes. This fungi is building soil, and it's an essential part of the system. Look how moist it looks. So also just think about how after a rainfall that will swell up and hold significant amounts of moisture. 3 inches of mulch, 3 inches of leaf litter can hold an inch of rain. And think about how that leaf litter holds that moisture above the soil, so it can slowly trickle down and permeate into the soil. So this is why we like mulches. We want to keep the soil covered. This is what we learn this is what we see when we look into maturing natural systems. This set of diagrams explores what happens as a landscape dries out, as the forest is removed, as the surface flow starts to accelerate and rainwater be lost, and how that then begins to change the water table and change the salinity of the soils. That we create long-term damage by degrading systems, and therefore to fix them we have to make ever greater interventions. These are our challenges. As the soil erodes, we start to lose our A horizon. We start to lose that area, the more aerated, the more dynamic, more fertile soils, and we get what gets left behind, something much poorer and then less able to sustain the plants that we need to build the system that holds onto the nutrients. I want to just bring, so we've thought about how water interacts now with plants, with soils, with landscapes, how things conspire together to trap and hold that water, and that extra, the more humidity we have, the more ability we have to form humus and to form deeper soils. As we erode into that system, the opposite happens. So we're building up and accumulating, or we're doing it wrong and it's breaking down and we're losing it. Let's just think about water, and I've said this thing about water flows downhill. Let's think about water and the landscape. How it interacts with the topography, with the shape of the landscape. Let's go back to Chimani. We get most of the rainfall at the top of the hill. As we move through the landscape, look how the shape of the hill changes. So we have this steep slope. So, and somewhere in the middle, we go from the convex to the concave. That's the profile we're looking at. And on this convex part of the steeper parts of the landscape, where the slope's greater than 20%, where we've got 12 to 18%, we want these to be forested. These upper slopes need to be forested. They need to be forested because of all the reasons we've just said. It interflows, it interacts with rainfall, slows it down, it rehumidifies the atmosphere, it creates more rainfall, it encourages water to soak into the ground and slows it all right down. Now in this diagram, we're encouraged to think about this very interesting part of the landscape where we flip from the concave, so the convex to the concave, when we go from, and somewhere at this key point is the sweet spot. And this is often where the settlement line is. This is often where people choose to put their houses, and where first within the landscape. And as we look at the lower slopes of the landscape, we're going to think, well, there's going to be much more humidity, much more moisture there. Water's going to flow downhill. If we've got good percolation into the subsoils and into the bedrock, then we're going to have springs and streams and issues happening in these lower slopes. And then in these bottom lands, we can do all kinds of farming and agriculture and encourage all kinds of different productivity. So understand within the gradient and the shape of the landscape about where we are and how there might be slightly different conditions at different parts of the slopes. On these steeper slopes, when we get above 18% slope, we want it to be forested. We want to have techniques that will And if it's not forested, then we're going to do techniques like net and pan and terracing and extreme intervention techniques to stabilize the landscape. On these lower slopes, we can start doing things like swales and berms and other kinds of techniques. And so that we can then increase our ability to do cultivation. Also in this diagram, let's think about how in the nighttime we get higher up, the air is cooler, cold air is heavier. So cold air is going to move down through the night sky, through the landscape. And if we're not careful, we'll get frost pockets and we'll get areas where cold air will sort of well up and affect the microclimate. So strategic placement within a landscape, understanding how heavier cold air might move down a landscape, then be affected by warmer air that's rising from below, and how we can create protected areas, we can create microclimates which might be suitable for habitation, for very specific cultivation techniques. Understanding the conditions change through the landscape. And if we can interact and slow down the flow of water higher up, then it's much easier to manage it lower down. If we leave the upper slopes bare and then try and intercept everything lower down with simple catchment techniques, we're going to become inundated and overcome. So we need to understand the shape of the whole landscape and have an overarching strategy as best as we can, or at least this is what we need to understand. So there's a lot of detail in ponds, dams, catchment. I think we'd like to go into that in a bit more detail in the future. The shape of ponds, we create more edges, more surface area, we get more interactions. These are simple design ideas, all around using and working with the shape of the land to catch and store energy, to slow down the flow of key resources through the landscape, understand how we can work with that and how we can slowly over time in increments create something that's of increasing value. There might be different strategies according to but there's always a way. There's many different techniques we can look into. It depends on how steep the landscape is, on the shape of the landscape is, as in what kind of dam or trapment we might want to do. Catch and store energy. This is another very lovely picture. Sorry, just reminding myself where we're going. This illustrates a few key rules, thinking about beginning to have concepts about how we go about trapping water in the landscape. Simple surface dams, porous dams. All we need to do to build water trapment is to slow the water down. If it's arriving faster than it's leaving, then it will well up. We don't necessarily have to seal surfaces with linings, concrete. We can achieve the same just by compacting the soil. In this illustration, we're seeing how these swales have been put to catch any surface water, any flow that doesn't go into the channel. It's going to come. Whoops, can I do that? Draw that? No, sorry. Any water coming into the system is going to be interrupted the flow, slow it down by making it go sideways, and then bring it back into the system and allow the dam to fill. Once the dam's full, where's it going to overflow to? We're going to create a spillway. We're going to create a direction for the excess water to go, where again, it's trapped back in the system and fed back in on the next level. Always try and make water flow along contours, and if there's a danger of it discharging or overflowing, then we support that with dense vegetation. So the rule of thumb is, if you have to discharge surplus water, you do it into vegetation where it's established. We slow down the flow so it minimizes the erosion, and if there's a danger of overflow, then we plant dense vegetation. And we try and all the time create another interception, send the water back into the system again. And look, here's a stepped chinampa. What we're seeing here is a set of strategies to make the water stay as close to contour as possible, make it overflow, and then come back and do the maximum journey. The longer the journey we can make the water do, the more work it can do, the more it can nourish plants, the more it can be absorbed into the soils and subsoils and contribute to rehydration further on down the valley system. Again, look how we have dense planting along this watercourse here so should the system ever overflow, that we've got, we can intercept the flow of water, we can slow it down, and we can reduce the erosion, and we can trap any soils. These are the principles. Now, in the second term, the second units of the course, I'm going to look at so many examples. I'm going to give you lots of references and things to go out and look up to see that there are really encouraging examples from all around the world, from all different climate zones, where people have worked with these simple principles to rebuild water systems and water courses, replenish water tables, catching and storing energy. Look how we've touched on so many different approaches and techniques. Those techniques might be unique to the circumstance, to the materials, to the priorities that you have, but they all fit into this bigger generality. And this is what I mean by seeing the patterns, seeing how water flows downhill, seeing how water interacts with plants, seeing how soil interacts with plants and how it builds itself. All of this is key. Slowing down the flow on higher, steeper grounds. Rather than building swales, one size fits all, swales are for lower down on the slopes. But here, what we want to do is so as water starts to form little rills and then become gullies and become deeper, and it becomes steeper and it gouges out more material. This is where we want to make our interventions as permaculture designers, to stop that water going downhill, make it go sideways. And then once you make it go sideways, you can predict where it's going to go. So look, there's an interception bank is being built here, which is making the water flow either to the left or to the right. And that surface extra flow is harvested by a little boomerang shaped structure built out of the materials that were there already, that's going to support the establishment of a tree, whether it's a successional soil building tree or whether it's a yield fruiting tree. We'll select that according to the state of the succession and the regeneration of the landscape. But we can make series of small interventions patterned so that it collectively has a catch and store effect, has a slowing down effect that keeps that humidity moving slowly through the landscape, and also getting a maximum opportunity to re-evaporate, rehydrate the atmosphere, and again fall as rain again. It's cycling, endlessly cycling. Yeah, there we go. So I hope this is coming together in a great. Thank you for that comment, Carolyn. I hope these sessions are coming together and we're getting a sense of these processes that are constantly going on around us all the time. That there's flows of energy, whether it's the sun or it's water, the sugars from plants, the organic matter, seasonal, and we can interact with these flows. You think of the energy within community, the energy in people around us. How do we catch and store that energy? How do we interact with those flows and get them to build systems? Chapter 4 is the next chapter in the designer's manual. Looks at I'm just going to, I'm taking a step back again, think about, so look, this is what nature does, understanding these systems. Our question is, well, as designers, how would we create that? It's all very well, look at a rainforest or look at a huge mountain and then say, no, go away and do that for yourself. How the hell would we do that? So we're gonna have to do some thinking, and that's the design part of our course. You know, we're doing permaculture design. We're asking ourselves, how do we take these ideas and use them to create change in the outside world? How do we take these observations and get them to help meet our needs? Okay, so this gets a little bit we're gonna do some baby steps here. Now, there's another session on patterns a bit further on, and we're going to go further into this. So this is about seeing big overarching patterns. And this is interesting, just the first thought is concepts of zoning in design. Oh gosh. Every time I come back to Bill Mollison and his book, it's just so incredibly dense and rich with information. And I'm always kind of, I think everybody's slightly overwhelmed just by the sheer amount of kind of knowledge and thought that there is in there. It's encyclopedic. I can't really stress enough what an amazing resource it is. And that's why I'm trying to go back to the source and make sure I'm not sort of overlooking some of these absolute gems. But how do we make sense of, situations? What we're saying is we do it by seeing some patterns. So here's a pattern. Here's a simple pattern. And look, here's our home. Here's our homestead. At the center of our world, the center of my world is my home. And around that home is the most intensive part of the landscape in terms of, as a designer, as someone who's gardening, interacting. Remember I said last week, everything gardens, everything is interacting with the landscape around it. Whether you're doing it consciously or not, you're interacting with it. You're making choices. As you walk across it with your feet, you compact the soil, you change it. It makes a difference. The area around my home, my homestead, my compound, is the bit that I see the most. I get the most information back from it because it's the closest to where I am. I spend more time at home and around in my compound than I do anywhere else. It gives me the most information. So there's a pattern here is those activities, those things that demand our attention, that we want to interact with the most. Ideally, if we're able to, we want to locate those closer to home. So even if I was to do, I started off this, so go back to the beginning, random assembly. What do we mean by that? Well, on one level, this is how nature does things, is it throws the seeds to the wind. It allows the birds to drop them randomly. The landscape can kind of be shaped and then by these sort of random forces. But once those seeds that land on stony ground, the ones that don't germinate or end up being eaten, they contribute in one way. The ones that land in the right place, where they get to germinate and that express themselves fully, contribute in another way. And this randomness is actually kind of not random. It's seemingly random events and form into patterns. There's something that we need to learn about from that. And as we get into the design process, we'll talk a bit more about how we use this as a design tool. I'm going to skip these slides just for this moment and go back to that thought about how if we were to scatter seeds over a whole wider landscape represented by this picture, the ones that we'd notice would be the ones closest to home. The ones that we'd interact with were the ones we'd most likely to pick or to weed or to pick the caterpillars off would be the ones closest to home. Or even around the pathway, the access to our house. We were going to interact with those areas the most, because that's how we enter and leave the property. That's where we spend our most amount of time. So it's really interesting to think about the placement of the things that we want to learn the most from, interact with the most. Strategically, we'd be wise to keep them closer to the home. So if we've just got the baby outside, we don't want it too out of sight or out of earshot in case it needs us. If we're cultivating seedlings that might need constant attention and care and attention and watering and maintenance, we want those to be either close to our home or close to our pathway in and out of our home, so that we see it, so we get the feedback, so that we can then interact with it and nurse it through its vulnerable earlier stages. We might keep some chickens, we might keep some other livestock. You don't want them inside your house. You don't want them tripping over, to trip over them every time you set foot outside. But at the same time you're going to have to go and let them out in the morning, put them away in the evening, feed them, milk them, collect the eggs, whatever it is that you're doing. So, but within the patterning of that, let's think about how often we interact with things and understand that where we place that in our landscape might be affected by and should reflect that level of interaction. So the more we're using something, the more we're utilizing a resource, the more we want it either closer to home or closer to our pathway or to our access, so that we can keep an eye on it. So zone 1 equates to the home, the compound, but the innermost zone. Maybe you only share that with family members, with your loved ones, with your children, maybe a few selected animals. That this is the home zone. So this is our first pattern to think about in terms of placement. Zone 1, let's call it zone 1. Zone 2 is, well, it's not the home, it's the bit outside of it. And in zone 2, you might overlap and interact with other people's zone 1s. So it might be a shared areas, or it might be an area where we have some cultivation going on, growing some vegetables, or interacting with with those things that we don't want quite in the zone 1 area. We can't put everything around our house. So some things that we interact with a bit less, we're going to push them a bit further away. So I might have my seedlings and my high maintenance vulnerable things close to my home, but then I might have my vegetable garden and my compost heap, it might be in zone 2, a little bit further away. I might share that with my other neighbors, with other close family members or people, community members, and we can have kitchen gardens that nourish both of our zone 1s. We can place things strategically, so it's not too if you've got to go and walk an hour before you even get to your vegetable garden, there's going to be days you don't go there. There's going to be days when you don't notice the subtleties of the changes and the interactions that you're making. So by understanding patterning in this way, and we begin to think about we might place things strategically so that they become more functional. And that's a very big part in design, is placement. Exactly the difference of getting something in the right place. Now, we've talked a bit about slope and aspect. We've thought a bit about water and soil. And so you understand, here we're looking at an idealized model. This land might not be flat. It's going to be shaped by the topography, by the water flows, by other things. But let's get into this more slowly. We've got zone 1 is home. Zone 2 is garden or community. So it's me, myself, my family, my loved ones, my more intimate relationships. Zone 2 might be my community, my neighbors, my friends, the people I'm cooperating with, regularly, people living around me. Zone 3, as we move further away from the home now, we're making more deliberate choices. We're spending less time there, But maybe when we're going into the zone 3 area, we're going further from home, we're going there with more reasoning, sense of purpose. This might be my main crop. This might be where I have my herd of cattle, or it might be where I'm growing my field of maize or my polyculture of different species. That if zone 3 might equate to work, to the world of work, we go there with a plan, we go there with intention, we're going there to grow things, to produce things, and we might be working together with other people. We might not be a farmer at all. We might be going into town and working in a white collar job or a desk job. That's still kind of like your zone 3 activity. You think about that. But in terms of landscape, in terms of farming, in terms of strategic placement, is again, and zone 3 might be affected by the access, the topography, the shape of the land, what kind of crops we put where. It's very rarely, the real world very rarely looks like this sort of target, sort of concentric circles. It's going to be shaped by many other factors. Zone 3 is our intensive seasonal agriculture, farming, it's work, it's also long-term collaboration with other people. Think of many characteristics of what zone 3 might be about. And so if you go beyond your fields, if you go beyond to the edges beyond that, what do we find then is, well, zone 4. Zone 4 is, it's the outer edges, it's the periphery. It's a place that you go to only occasionally, maybe seasonally, just once a month or a few times. It might be where you go to gather wood, where you're growing your teak trees or long-term crops, things that don't need your constant input and interactions. I might even have orchards out in zone 4, things I only need to perhaps go and visit 2 or 3 times a year, a bit of pruning, a bit of mulching, harvesting. But then I might plant some of my fruit trees actually over here in zone 2 also. So when I see that they're coming to fruit here, I'm prompted to make a journey out into zone 4 and see how the ones that I'm doing out there are progressing. So strategic placement, understanding a generality of a pattern. And this is zones. This is a very simple patterning idea in permaculture of zones. In a purest way, we think of them as concentric circles moving out. But of course, in reality, it's never quite like that, because the land, the access, it shapes it, pushes it one way, the slope or access will shape it in another way. So what's on the outside of zone 4? So we're moving from our, say, more intensive pasture cultivated systems. We might through tree crops, agroforestry, fuel crops, hedges and edges, and the periphery of our land. Beyond that lies zone 5. Zone 5 is wilderness. Zone 5 is the bit that we can't maintain. It's beyond our control. It might be our neighbour's land, it might be owned to someone else, it might be a road, but it could also be wilderness. And really, in its purest sense, zone 5 is the wilderness. Zone 5 is where we go to learn, to get new ideas, to observe nature. Nature is our teacher. We go into nature, we get new ideas. And we learn those, take new ideas, and we take them home and we apply them in our zone 1. So there's a connection between the outside, it's like to see the view, to see the picture, you climb the mountain. And from the top of the mountain, you can see the whole valley. You can see where your little place fits into the big picture. But you don't, and then you take that perspective with you back to your home, and you understand that, this is my place within the landscape. And that helps you then inform your design, inform your strategy, and build your plans. So there's an interesting relationship between zone 5, the outside, the wilderness, the distant, the far away, and the zone 1, the heart of the nub, the home. Look how in this diagram, there is a kind of a wedge cut out. And it says here, wildlife corridor. And what the suggestion is here, that zone 5 is so important, the random assembly. No one's planting the trees in nature. They're just choosing when, chance, gravity, interaction with other species allows that to form through a random process. That's constantly renewing itself, and it's constantly informing us and giving us ideas. Maybe zone 5 is so important. Zone 5 in our zone 4, our zone 3, our zone 2, and even in our zone 1. We need to have some unmanaged areas. We need to allow wildlife, the species we didn't think about, the ones that perhaps we didn't understand the value of, they still need somewhere to be. Where are the slow worms or the lizards going to hang out, or the, I don't know, where the certain birds are going to have their nesting sites. Often, and if we can connect to zone 5, if we can connect from the inside to the outside, then there's a possibility of new ideas, new materials, new people, new connections to coming in as well. If we're closed off, then we're going to become increasingly static. So nature always benefits from being connected to the outside. So even think about this, imagine a little island and it's a closed system. There is kind of no zone 5, it's all on one system, but then a bird flies over and drops a bit of bird dropping, and in there are some seeds, some microbes, some information, some DNA from the outside. That is zone 5 connecting back to zone 1 again. So in our designs, we want to understand our place within it and to see those patterns, and then from having understood that patterns, then to build strategies. So we place things strategically, but we give the ability for things to learn and grow and develop beyond our absolute control, because we're never in control of everything anyway. Even if we think that we are kidding ourselves. There's much more going on there. Okay, there's some really lovely ideas here. I'm going to, let's just check on the time. Okay, we got a little bit of time. Okay, but there we go. Pattern understanding. Okay, these ideas are about succession and we'll come back to this. It's such a huge subject. Okay, I'm going to close it off by looking at some generalities. This is our final little bit, and it's interesting just to see the patterns in nature. So look, here we have this, we're seeing a tree, but here we're seeing the whole tree. We're seeing it above ground and below ground. And look, there's a balance, there's an equivalency, isn't there, between the canopy and the root mass. So think about, that's an interesting thing right away to see that that's a certain kind of pattern. Look how the tree, we have a stem, we have the trunk, but how the tree branches and branches. It's creating surface area. The tree wants to interact with the atmosphere. It wants to photosynthesize. And then in the roots, it wants to create as much surface area to create exchanges with the soil microbiome, with the soil biota. So again, think about how the roots branch and branch and branch to create surface area, create edges. And from those edges, there can be nutrient exchange, there can be relationships can build, and which is the constant process of what plants, of course, are always doing. There's some real in-depth investigations within Bill's book about patterning, and he's so interested in this cardioid model, this shape which kind of reminds us of the tree, of the stem in the middle, and the branching above, and the branching below, and how this shape actually tessellates together and can fit to create many other more complex shape built on repeating patterns fitting together. Now, I'm not going to get too esoteric on all of this, but there's something very deep within this that's ever so important for us to begin to understand. These patterning, it's a very, very simple pattern, right? Is you start with a stem, a single strand, and what you do is you halve the distance. So the next stem is half the distance, but you branch the tree. So we move from a single stem to 2 shorter stems to 4 shorter stems, and then see how we branch and branch. Dendritic branching. We see this pattern everywhere, don't we? We see it in trees and rivers. We see it in our own sort of distribution system, in our lungs, in our blood system. It's a pattern of dispersal and collection. Now, we're going to get further into this in the future, in the future lessons, but I'm asking you to observe, to use your powers of observation to start to see that wherever we look in the natural world, we see patterns. And those patterns have sort of functions that in some way inform us about the natural world. Now, I said to you, water flows downhill, and indeed it does, but it doesn't go in a straight line. And this is something which has been very interesting, and this is another observation that I'm going to encourage you to make. I've said before, don't believe anything I'm telling you. Go away and test it. I'm sharing my perspective with you, and I'm challenging you to go away and test that perspective on reality. Permaculture is about you observing and interacting, understanding this for yourself, and making these ideas your own, or understanding them in your own way. And one of the observations that we make about water is, yes, it flows downhill, but it meanders. And that's something to do with friction. It might be something to do with the turn of the earth. It could be something to do with the characteristics of water itself. And a very clever gentleman, who I forget the name of, created a thing called a flow form, and it accentuates the characteristic of the fact that the way that water moves. So we see water's entering the system here, and if the water chose to, it could flow directly through the system in a straight line. What happens is it enters the system, and then it flows around one side and then around the other, and then comes out in a figure of 8 shape. And we talked about these Ekman spirals, the way that water crosses through the landscape. There's a corkscrewing, spiraling effect, sort of hardwired into the way that water moves through landscape. And this is very interesting. And as perhaps the water moves through the system of spirals, it can fold in air. There's more interactions. Again, it's not going straight downhill. It's going downhill, but it's going down in a corkscrew spiraling fashion. These are, again, patterns. We can start to bring those into our understanding and bring that into our way when we observe the natural world, can form in terms of what we're seeing. I'm interested in scatter patterns. This is like wind dispersed seeds. Think about that, how nature sometimes just saturates the environment with seed and then lets it fight it out. That's a genuine random assembly. It's a genuine process of design, but it's not very resource efficient. We use an awful lot of seed before we get some results. Patterns that we see everywhere, spider's web. Here's one I like about this is, we see a spider's web and we go, aha, that's a spider's web. But actually, every spider's web is different. There's never two the same. Different species of spiders make different kinds of web. Different individuals make different kinds of web. Maybe an individual spider on a different day will make a different kind of web. That the web is an interaction between the environment, the anchor points that it's chosen, and obviously the wind, and something might break, and something might be affected by another insect. So whatever that spider is creating is unique in that moment. It's an interaction of varying different forces, but even though it's unique and we've never seen it before, we recognize it immediately because we see the pattern. We recognize that wider pattern. And then we think about, well, the web, it's a bit like a fishing net. There's a functionality to that pattern, isn't it? There's a reason why the spider has created that particular design. And it must be a relationship between its function, like it's got to work. If it doesn't catch insects, the food for the fly, for the spider, the spider's going to die. And it needs to be efficient. It needs to be resource efficient. So the spider's using the minimum amount of resource, the minimum amount of energy, the minimum input to create the maximum effect. And this is, again, without getting lost in the detail, this is something we want to learn from. This is nature's patterns. Mycelium. Here's a block of agar, of nutrient that's been impregnated with mushroom spawn. And then the mycelium is growing out from that, fanning out in a dendritic splitting fashion, very much like we saw for rivers, because it's exploring the environment around it, looking for its next food source, and creating as much surface areas as it can so that it can absorb nutrients from its environment. These patterns in nature are universal. They keep occurring again and again and again in different examples. All of this is going to inform us and give us ways forward. It's mycelium in Gunther's paper. And look how we're seeing that same branching pattern, how much that looks like the arterioles in your eye, or in your skin. That there's something about this patterning that relates to the function that it's performing, and something that we can learn from that. And we can keep asking ourselves the questions about that. Spirals. Here we've got two patterns actually. We've got a lobed pattern, and look how the individual scales, approximately 6-sided. I'm not sure if they all are, but we have kind of little hexagons. It's the skin of a chameleon. And also then look about how it curls up on itself as well. So we've got spirals and lobes. And spiral in a snail shell, spiral in a plant. Look what happens when you push soap bubbles together. You get 5s and 6s. We get hexagons, and actually we've got some pentagons. These are telling us something. And actually, look, the shape of those hexagons and pentagons are kind of similar to what we're seeing on the skin of the chameleon. These are patterns that occur in nature in many different examples that we can bring into our design. We can bring that into our planning and strategies. Again, this will be things we enlarge on later on. Snake skin, similar to the chameleon. Just really fascinating to see that there's a functionality behind these patterns, and there's something that we can learn from it. And there's a universality of it as well, that the same patterns occur again and again in different contexts. So much we could there to learn from nature. Now, okay. Final thoughts for today are around edges and surfaces, and we're interested in diversity. We're interested in the subtle differences that happen in systems. and we thought we thought about, we talked about water, we talked about flow. Let's explore this diagram. That here's our branching dendritic patterns. There's water coming together, little runnels and rivulets forming beginnings of a stream. You can see here, look, here's our drainage catchment, label number 12, and then there's our water coming in now through our landscape. And that water's accelerating as it comes down the hill, and that's obviously going to slow down as it enters the lake. And you can see how the through flow of water sorry, someone's trying to message me. I'm going to have to, how do I? Okay. Sorry. Lost the share. Actually, look, I'm on. Stop share. I'm going to wind up a bit actually, because I think these are very long lectures and there's quite a lot to think about. You get differences at edges. And this diagram really begins to explore this. It's thinking about how a water flow, how here in this channel it's going to be flowing. We've got an edge between the river, new water entering the system is going to flow, and it's going to create edges. It's going to interact with the still water that's already there, which means it's going to, fast water holds sediment, slower water doesn't. So it's going to be deposition. We get different sets of conditions along edges. Now look, this is one of the things I want to go again much more deeply into is by an edge, so many different edges in this picture, we mean where two sets of conditions come together, wet and dry. So if, look, simplistically, on the edge of this pond, of this lake, there's a wetland system, there's a marsh system. It's not quite soil, it's not quite water. That creates a unique set of conditions where we can have a completely different type of yield, a different type of set of plants, and that where we might have more interactions here because there are advantages of both land and water occurring in this space. That there are different characteristics to the water that's high up in this system, and there's different characteristics to the water that's lower down in the system. The water that's moving and the water that's still creates interesting little edges around it where we get different conditions and then different interactions start happening. Think about the temperature gradients between the surface of the water and we go down deeper into the water. These are all things that we might want to explore in design. That that the surface water has more light, it has more oxygen, but it's also maybe more vulnerable to predators, or different set of conditions exist. And if in a designed system informed by nature, we can create a variety of different habitats, a variety of different conditions, and then what we do is we create then the possibility for many different diverse species to find their optimum. It's not too wet, it's not too dry, it's not too hot, it's not too cold. Can find the right set of conditions within that system. So beginning of thinking about edges in design, edges as unique sort of little habitats and unique opportunities, and how those edges actually might also be sort of pulsing and vibrating and moving because we've got an interaction between two different forces, between the air and the land, or the water and the land, and the different conditions. And how Just a simple thing like an edge might be, where a woodland comes into a grass, but maybe where there's a fence, and that fence might actually create a change because it slows down the flow of air, so there's going to be more deposition of organic matter. Maybe birds might rest on that and perch on that fence, dropping off phosphates and seeds, and they're dropping into the leaf litter that's along the fence. We've got a slightly unique, slightly different change of conditions in which there's a benefit because there's a combination of factors happening. So we're very interested in edges. We're interested in exploring how small interactions, for small interventions, can create knock-on effects. We want to understand how these dynamic systems work, how it works in nature, how we can be informed by that, and then bring that into our design. So there's a reason is that these natural patterns keep reoccurring. It's because they're functional. It's because they do the job that they need to do, and nature constantly builds on its own successes. You'll see patterns repeat again and again. If they work in one set of conditions, they might work in another. And that's something then also that we can learn from as designers. We can take these concepts, we can understand these patterns, and we can begin to share these ideas in a way in which we can build long-term strategies. Our strategies are, we're using our observation of nature, understand processes like succession to catch and store energy, and as we move into next week, to build designs that help create yields that meet our needs. Seeing patterns so that we can catch and store energy and build yields, to see where we might invest our energy, where we might make interventions, where we might put scarce resources so that we can create the maximum effect. And if we're running out to the top of a hill to plant a tree, we're not going to go back and prune it, or water it, or look after it as often as if it's closer to our home. So we're going to think strategically how we can move from simple systems to complex systems, how we can let natural forces, natural flows accelerate the designs that we are creating through our interventions. Whoa. Lots of thoughts and ideas. Please do, yes.
Yeah, it's another really simplistic question, but because I'm typically computer bound, looking at the computer the whole day, have no clue about garden. I haven't just a garden, right? I don't have land. I don't have all these, allotments. So it's a really simple question. Can you give practical guidance about not what you mean, but really practical things when you say go and observe? So should I literally go into my garden every day and have a little notebook and go, oh, it rained yesterday. Oh, and I can notice these changes. I mean, what does it really mean to go and observe? What am I supposed to actually do? Because I can sit in my little office now in the winter and just not go in my garden and just think, well, it's winter, nothing's happening there. I just only need to go when I need to plant something. So what is the practicality of
Great
going?
question. Lovely question. It's good to observe your land, the environment, what it is you want to understand at extremes. What's it like when it's been really, really cold? How's the frost lie? What does that do to the plants, to the soil? In the winter, when the leaves are off, you see it's like the ground is naked You see it for what it is. You see through things. So it's very important to observe things in its extreme. The winter's a great time for understanding that. After you've had a really cold spell, how does it thaw? Are the pockets that remain frozen? Are there other areas that catch the sun? Understand your microclimate. You can never underestimate how important microclimate is. It's the difference between one bit and another can be key. How does it look like when it's been raining? When it's already saturated and then it rains again, how does that water leave? What happens to it? Where does the surface go? How does the soil absorb water? What happens when it hasn't rained? As it dries out, are there some parts of your ground which are more readily, dry out faster than others? Ask questions. Why is that? What happens if I stick a stick in the ground or dig a hole and I can observe like that? I can take a handful of my soil, take a handful of your soil and feel it. How does it feel? Is it sticky like clay or is it crumbly like sand? Describe it. Come up with some words in your own mind. How does it feel? When you clump it together, if you roll it, does it stick or does it fall away? When we look into the soil, do we see a crumb structure? Can we imagine that it's like little beads with air spaces between them? Now, we told you that healthy soil is 50% air by volume. And if your soil isn't like that, then why isn't it? Can we ask questions about why is it compacted? These are the beginnings of the observations that you might make. So always a good observations to make is, what weeds have you got? What are the plants are volunteering to be there and choosing to be there? Is that telling you anything about the quality of your soil?
You have to
Is
know
that telling
what
you
a
about?
weed is. You
Well,
have to know what a weed is.
I actually try and ban the word weed and say let's not use it, because actually, they are pioneer plants that germinate in damaged and bare soil, and they grow very, very quickly. But they're volunteers. So actually, the kinds of plants that you didn't plant, the things you did not put there, that choose to grow there, that's random assembly. That's nature telling you something about your ground. You might not know what, but it's telling you something. If it's buttercups, it's telling you one thing. If it's docks and something like that, it's telling you something else. If and again, if the ground's wet and heavy, you're probably going to get the buttercups. If it's dry and compacted, you're going to get the docks. If the thistles are in it, it's telling you something. We might take us a while to figure out what it's telling us, but if you don't make that observation, you're not receiving that information. What birds choose to come to your land? What insects do you notice? Or are there any? Is there a lack of them, or are there lots? Are there more this year than there were last year? Did it change? What intervention did you make that might have had an impact? I mean, sometimes they might be tiny things, but also you might make those observations walking around your neighborhood, walking in the park, in other wild spaces, or look into other people's gardens and see what they've got going on. Again, if you see a real success story or something that's really got its own energy, and that's telling you something. Whether it's your next door neighbor doing something successfully or something random that's happening, that's giving you a clue about the potential of the landscape that you're within. And look, what you want to do with that is 100% then down to you, because you're the designer. You're designing to meet your needs. Remember, that's your priority. You, community, nature. So that's what we're trying to do. But the first question is, what are your needs? What are your priorities? Is your garden for aesthetics? It's going to look nice. Or I care about bees. I want it to be good for pollinating insects. Or are we growing food? Are we growing fruit trees? Are we growing things that smell nice? Or what are all of those are your priorities. But we won't do those achieve those goals, those yields, in a way in which it works with the natural force of that natural system, of what it wants to do. So you're not rolling rocks uphill all the time, fighting against, you know, oh, these blooming things keep coming back. Well, they're coming back because they're trying to do something. They have a reason, they have a function. We have to understand that these volunteer plants, they are performing a function. They're responding to a need in the environment. They're not just doing it to annoy you, although it might feel like that. Thank you. Great question.
Yeah, thanks a lot. I think I need, first of all, a course on plant identification, on tree names, on bird names, on identifying insects. I'm just like a total zero knowledge on those things. So it's really interesting.
Okay, those are all tools of observation. So even if you don't know what it's called, you can give it your own name. You can begin to spot those things. And then after you've seen it a few times, someone might help you with the name. Oh, that's a shield bug, or that's an ash tree. But start to say, what does the bud look like? What does the leaf look like? What does the seed look like? Can I see a pattern? Is the edge of the leaf serrated or smooth? Even if you don't have a name for it, you can begin to inform. Like, that's why I'm showing you those pattern archetypes. Is it a web or is it a river? Is it a branching pattern or is it a web pattern? Is it a spiral or is it a, this is us beginning to have a language of observation. And if everyone in the UK, come to Trevlack Farm and I'll show you around. I mean, the one thing we can't quite do is all the practicals and observation that we would do if we were in the field together. And but I'll try and bring these elements into the PDC as well. So thank you for the question.
No, that's very helpful. Thanks.
Hi, Steve. Hi, everyone. Yeah, that has been brilliant. However much myself, I'm on the team and one of the co-facilitators, but I find myself always learning and learning. And when it gets to observe and interact, or that, active observation is one of the sessions I get to enjoy so much. And really is always awakening, if I may to use that, to get to learn from nature, to observe. Apart from the, as Steve already says, the standard or the universal principles, things like water always flowing downhill, but also going into the intricate details, or trying now to get a third eye to observe deeper than that. That way, that also gives us, if we are to really learn from nature, it gives us a connection. Unless you connect with a teacher in one way or another, there is no way you're going to learn. So this deeper observation also gives us a deeper connection to be able to actively learn from nature. Thanks, Steve, and thanks for everyone for, attendance and the active participation.
Thank you so much, Jared. Thank you so much, Jack. And thanks to everyone who has contributed for today's session. It was really lively, and it's really so enthusiastic to see that we are bringing out the relevant and also specific examples. I'm just so grateful that permaculture could create us possibilities, as well as opening up new opportunities at the same time. So, big ups to everyone.
Any other final comments from anyone? You're very welcome. Just to say hi, even if you haven't got anything to say.
Hi, everybody. Hi, Steve.
Hey, Hannah.
Yeah, just amazing. It's always great to go back to all the kind of foundational stuff and from a perspective of different people on this call being in different countries, it's like so interesting. I'm in Ireland. Don't know exactly where everyone else is, but definitely a few different climates here. And to see that even though some of those like these climates might be so different, like particularly when you're talking about the water, here we have an abundance of water. And a lot of the permaculture stuff initially tends to kind of address water scarcity. At least when you see techniques and stuff online. So for us here to be kind of applying those patterns, there's usually a lot of adaptation to do. And I find that the pattern to detail principle is really, well, to me, I kind of think it's the most important. I know they're all important, but really they're all important, but really that's the most important, and also can be the most challenging for people to understand and to kind of get a grasp on. And I maybe perhaps because we've kind of been, things have been, at least in our culture here, has been so fragmented, like both intentionally and unintentionally. You know, you kind of specialize in one thing, you get educated in one thing, you never really get this education where you see the whole picture and you kind of learn to see how things are linked together. Maybe some disciplines do, but doesn't seem to be very common. And then when people start to learn about patterns, it can seem a little bit alien. At least that's been my experience kind of teaching it. And it can seem a little bit too simplified. You know, people think like, yeah, okay, but then when you start to apply them, there's all these complications. And it was something you said, I forget exactly what you said, but it was something like I think it was when you were looking at the zones and you were saying that it never looks like that. It's just a concept. And that's really almost the case with all the patterns and the pattern understanding. So it can be challenging. That's where my long-winded way of getting to that, saying that. Yeah, it can be kind of challenging, but on the other hand, then when it does land, it makes things so much faster, and it seems to just make everything so much easier. So it's well worth trying to kind of get a grasp on. And there was a lot in that. So thanks very much.
Thanks, Hannah. You know, it's interesting. At some point, we were doing a training. So we were talking about sectors and zones. So because the illustration or the diagram is like circular and as if they are well drawn out. So at some point, we moved out to go and do the practical and also try to identify or look it up. And to the learners, to some of the learners, they were assuming it's obvious that it's going to be circular, and they tried to, you know, to zone it out in a circular way or try to make it as, you know, as obvious as it seemed. But then when you go back, you're like, okay, if you're really now going back and taking a step, you're saying how most of the things within nature, for a reason ABC, are usually amorphous, and probably that shape also has a function to play. If you're going to start thinking, you know, in a specific direction or shape, then it's going to go back to the conventional way of thinking and the conventional way of doing things, which probably in permaculture we wouldn't want to encourage, because you're trying now to create diversity, not just in, let's say, demographic or element-wise, but also in terms of learning, create diversity for that in any way. I don't know if it makes things more complicated or simplified.
Yeah, totally. Like, it's kind of like, it's not that it can come across like you're just giving a load more, like a whole different set of tools, like, oh, here's the conventional way, but this is the permaculture way. But yeah, to be kind of aware that that's not, you're supposed to take it and run with it and kind of evolve with it and be creative, and not just kind of lift it and place it onto your own scenario. Yeah, it's a good point.
Yeah, every individual situation is going to be unique, and your preferences are going to be unique. So even if you could make the landscape the same, you're still actually going to want it to do something different, and that's the key thing. But the patterns are universal. The instances are always going to be unique, and that's to say you recognize every spider's web, but every spider's web is different. Okay, we've used up our time. I'm going to thank everyone for their participation, and we have recorded this, and we will be capturing that. And I look forward to seeing you next week. And please do. Oh, thank you for your comments, Carolyn, and everyone else. Really, please do. We'd love to and send us messages. We'd love to hear back from you. And otherwise, we shall see you next week.
Thanks, Steve.
Thanks all.
Bye, everyone.
Bye.
Yeah.
Bye-bye.
Bye.
Bye-bye.
Thank you. Wonderful presentation.
Gloria.